Hello, and welcome to lesson 18.2 on using similarity criteria. So in the previous lesson, we discovered our similarity criteria. So side, 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 and angle to prove if two triangles were similar. Now we're going to show if they're similar and then use that knowledge to solve some problems. So we have Clarissa is one of the surveyors hired to help determine land boundaries. She needs to find the distance across a ravine, which is like a big kind of hole in the ground. She thinks that she can use the properties of similar triangles to find the distance. She locates points A, B, C, and D and E and takes the measurements shown. So similar triangles are really used in surveying and like not construction because you're not building things, but constructing diagrams of the land, etc. All right. So make sense of problems. Which similarity criteria, if any, can be used to show that triangle ABC is similar to triangle DEC? So let's look at this picture over here. So I notice I have two sides in my left triangle and I have two angles in my left triangle. So if I know my two angles, I can find the third one by subtracting them from 180. So if I do 180, take away 64, take away 61, I'm left with 55. So I know angle E has to be 55 degrees based on our triangle sum theorem, okay? I do notice some vertical angles. So this other angle C over here is 61. So based off of that, I know that I have a 61 degree angle in one triangle. I have a 61 degree angle in the other triangle. I also have a 55 in one and a 55 in the other. So that right there is angle similarity theorem. So I know these two triangles are similar because they have all the same angle measurements. So I would say yes by angle similarity theorem. Okay. So since I know two angles are equal to two angles in the other one, I know my two triangles are going to be similar. Okay. So if they are similar, now I can solve the triangle. So, move my face. The triangles are similar, so the corresponding sides are going to be proportional. Complete and solve the proportion to find the distance AB. So let's color code our diagram to help us out using this similarity statement up here. So I know AB, the first two letters, is going to be proportional to DE. So I'm going to highlight AB green, which is what I'm trying to find, and then DE green. So those are the corresponding sides. I'm going to go purple here. BC are my last two letters, and EC are my last two letters. So BC is going to be proportional to EC, and then I'm going to leave the other two sides blank because they're going to be matching up. Okay, so I'm going to set up a proportion. I don't know anything about this purple side, so I can't use my purple colors. I do know the blank sides are proportional, so I am going to have to use 65 and 85. I'm going to start left to right, so I'm going to say 65 over 85. Okay, so if I started in my left triangle, I have to continue in the left triangle, so I'm going to use my 55 over my right triangle, which is AB, which I don't know. So you can either write X, I'm going to write AB for right now. So now I can solve for AB. I'm going to cross multiply. So I'm going to do 85 times 55 to get 4,675 equals 65AB. Need to divide by 65 now. So divided by 65. So I know AB is somewhere around 71.92. So I'm just going to write 71.9, and we have units, so 71.9 meters. Okay? So that is how I first determine if something is similar, and if my triangles are similar, then I am allowed to set up a proportion and solve. Okay? This is called indirect measurement. So Clarissa measured the length of the ravine indirectly. So we didn't physically go over there and measure the line segment. or however long the ravine was, because it wasn't possible. So indirect measurement is a technique that does not use a measurement tool such as a ruler to measure an unknown length. Indirect measurement is used to measure distances that cannot be measured directly, such as the height of a tree, distance across a lake, or a ravine. So similar triangles are often used to make indirect measurements. So true. So the most commonly used example is to measure trees. And so what they do is they find an object and then they find its shadow. So they measure the object, for example, your height is something easy to measure. And then you can easily measure your shadow on the ground. And then you can find a corresponding shadow of a tree, and then you can solve a proportion to figure out how tall a tree is without actually walking up the tree, or not walking up, climbing up the tree, okay? So if it's sunny one day outside, we can definitely go and find how tall a tree is based off our shadows in indirect measurement. So cool. All right, let's look at another example. So we have Clarissa again. She needs to find the width of a rock formation in a national park. She locates points A, B, C, D, and E and takes measurements shown. Find the width of the rock formation AB. So I'm trying to find the base, AB, okay? But before I'm allowed to set up a proportion or solve, I first have to see if the two triangles are similar. So I don't really know many angles, but I do know some sides. So maybe I'm proving side, side, side. However, I don't know this third side, so I'm not proving side, side, side. So maybe side, angle, side will come into play. And so if you notice, I have a triangle on top of another triangle, and so that means they are sharing angle C, which is kind of like the reflexive property. So if you have something on top of something, you know they are going to be sharing that piece if you split it apart. So because angle E is going to be equal to angle E by reflexive property, that gives me an angle, okay? So now I maybe need to check some sides. So I need to find this smaller side CE and this smaller side DE. So I know the entire length of AE is 84, and this part is 36. So to figure out what's left, I'm going to subtract those two numbers. So 84 take away 36 is going to be 48. So I know CE is 48, okay? On this right-hand side, I know the entire length is 98. Part of it's 42. So if I subtract them, 98 minus 42, I get 56. Okay? So now I can check to see if my sides are proportional. So I'm going to look at this small triangle. I'm going to highlight it in green. And then I'm going to look at my bigger triangle in blue. Okay? So I already know they share E in common, so that's an angle. So let's check the sides. So here's how you check proportionality a new way. So I'm going to say 48 over 56. So I said the left side over the right side. So now I'm going to check the left side of the big triangle, which I know is 84, over the big side in the other triangle, which is 98. Okay? So I checked left side over right side equals left side over right side, and I'm looking at my bigger triangles. Okay, so if this proportion works out and they equal each other, then I know they are proportional. So let's try it. So 48 times 98. 48 times 98 is 4,704. I'm going to see if that equals my other two multiplied, 56 times 84, and it does. Okay, so since my numbers equaled out, I know my sides are proportional. Okay, so I know that CE over DE is proportional to the whole thing AE over BE. Okay, so I know an angle and I know two sides are proportional, so they are going to be similar by side, angle, side, similarity theorem. Okay, so first off, before you solve a problem, you have to first make sure they're similar. So again, if you have an overlapping triangle where they're touching, they're going to be the same angle. So that will be the reflexive property. And then I just checked two sides to see if they are proportional by doing part over part equals whole over whole. They do end up working out, so they are similar. So now I can write a proportion and solve for AB. So you have a lot of types of ways you can write your equation. Since we know a lot of information, we know a lot of sides. But I am trying to find AB, so that is going to be my base. So I know I'm going to have to use my base and my base. Okay? So I'm going to have x over 54. Okay? So I have base over base. So now I need to do a side over a side. So you get to pick. You can pick the left side of the triangle or you can pick the right side of the triangle. I'm going to do the left side of the triangle. So I said the big one over the small one. So I need the big length, which is all of this side, which is 84, over my small length, which is 48. And I would cross multiply and solve. If you wanted to do it a separate way, I'll show you all that way. Let's say I wanted to use my right side of my triangle. I could have 56 over 54, because it's my right side of my base. So 56 over 54. So I did side over base. So I need to do the side of the blue triangle, which is the entire part, which is 98 over x. Okay? Does not matter how you solve this, you're still going to get the same answer. So over here, you would multiply 54 and 84, and then divide by 48 to get 94.5. If I do it on the other side just to check my work, I would multiply 54 and 98, and then divide it by 56 to also get the same thing, 94.5. Okay. So the biggest thing we just figured out is when you are trying to find a base, which is the bottom of the triangle, you cannot use these little parts because they're like half of a trapezoid. Okay, so you have to think the part of the triangle and then the entire large triangle, which is the entire side added up, which is a little tricky. Okay, so that is how you solve a triangle. So let's look at two more examples. All right, so again, I have an overlapping triangle over here. So I'm going to show you another way how to do an overlapping triangle because maybe that will help you out. So I'm going to split these two triangles up. So the first one is my small one, which is CBD. Okay. My bigger triangle is the whole entire thing CAE. Okay. So this may help us out. So my smaller sides, I only know the base is 20. That is all I know of my small triangle. The big triangle, I know the base is 35. Now the tricky part is what to do with this 12. Okay, so I'm ultimately trying to find CB. I'm going to put an X here. So I'm going to go ahead and put an X over here. Now, to find this entire thing from A to C, you are going to have to add these two lengths together. So for example, let me flip back. Over here, 36 plus a 48 gave me my total, okay? So if I'm trying to write an equation, I'm going to have to add the 12 plus the x. So that's what I'm just going to write, 12 plus x, okay? So if you have an overlapping triangle, you can split them up. Just make sure to get the whole entire thing, you're going to have to add them together. So the whole thing is 12 plus x. Now this may help you visualize this better. So now I can do my proportion of this over this equals this over this. Or there's 4 ways you can set it up. That's just how I like to do it. So I'm going to say, I'll do the opposite. I'll say x over 20. So I said left side over base equals my left side, which is 12 plus x, over my base, which is 35. Okay, if I looked at my together triangle, so I said the left side over the base, left side over the base. The trickiest part is just to make sure to add those two lengths together. So now I'm going to solve them. And it's a little bit trickier because I've got two things in the numerator. So x times 35 is 35x. And then I'm going to have to multiply 20 times all of that. So I'm going to say 20 times 12 plus x. Okay? Now I'm going to distribute 12 times 20, 240, plus 20x equals 35x. So now I have a variable on the left and a variable on the right. I'm going to get my 20 to the left side by subtracting it. 35 minus 20 is 15x equals 240. Divide by 15 to get 16. Okay. So, not going to lie, overlapping triangles are a little confusing. One, because they're hard to visualize. Okay. But my value of CB is going to be 16. So CB equals 16. Okay. All right. Let's try another one. Oh, real quick. The reason I was able to solve this problem was they have C in common because it's overlapping. And then they have another angle, so that says angle-angle similarity, which was why I was able to solve it in the first place. Okay, over here, looks like I have a side angle on a side. Nope, I have an angle and angle. So here's an angle, here's an angle. So since I knew two angles in one triangle and two angles in the other triangle, I have angle-angle similarity, so I can solve. So XY is here in red. I don't know what it is. Okay. Let's color code our triangle. So that is going to match up with this 30 side. And then my 22 side is going to match up with my 38 side. And now I can set up a proportion. Again, there's 4 different ways to do it. I'm going to do it this way. So I'm going to say 22, blue side over red side, XY, that I don't know, is going to equal, so I said blue over red, so now I got to go blue over red, so 38 over 30. Again, tons of ways to do it. You could have said 30 over X equals 38 over 22. Tons of different ways. But I'm going to cross multiply 22 times 30, 660 equals 38 XY. Get rid of the 38. Get rid of the 38 by dividing. So my final answer is 17.36842, which is a long decimal, so 17.4. So XY is going to be 17.4. Okay. So you can get decimals in this stuff. Don't freak out. You will get decimals. Okay. All right. So that's an example of how to solve for missing sides in a similar triangle. I want y'all to try the next 3, 4, 5 on your own. So press pause and then I will go over the answers. I stared at number 3 for so long because his math is correct, but he didn't prove the triangles were similar to begin with, which is the tricky part. So all I know is I have an angle and I have an angle. And I would need to know another angle, or I would need to know all the sides, or I would need to know another side to do side angle side, but I don't. Okay? So he can't even solve this problem because the triangles are not similar. So don't fall for that mistake because I did. All right. Number 4. A wasn't too bad because if you realized it was 60 and 60, that all of the angles are 60, which makes it an equilateral triangle. So I know all the sides are the same. So all the sides over here were 18, all the sides over here were 21, so I am done. Okay. B was a little bit more work. So, and you do get a decimal, it was okay. So you had an angle and an angle. And then I first had to see if they were proportional. So I did 12 over 32 equals 15 over 40. And I cross-multiplied and I got 480 and 480, so I know my sides are proportional. So by side angle side similarity, I was able to find my final answer of RQ. Okay? So to find RQ, I did it this way. You could have done a lot of different ways. I said 15 over 40 equals 16 over x. You could have had 12 over 32 equals 16 over x, or any other combination of that. But you do get 42.7. I rounded it. Okay. Let me know if you have any questions on how to prove if it's similar, and then how to find a missing side. On number 5, I also stared at this one for a while. So her work was incorrect. So first I color coded my triangle. I like to color code. And so 9 matched up with 12, so they went, or 10, so they went from the left triangle to the right triangle. So then you would have to start in the left triangle, which is EC, which I don't know, over 8.75. So she needs to flip that second fraction to match it up with its corresponding side. You also get a decimal here. I rounded it to 7.88. Okay, meters. I should put a little M for meters. Attention to detail. Okay. All right. So that is how you solve a similar triangle after you prove it's similar. So let me know if you have any questions. Otherwise, you can practice.